Welcome to another edition of Teach the Geek interviews. My name is Neil Thompson. I am the founder of Teach the Geek. It's an online platform for science and engineering professionals, and I also work with technical professionals so they can present more effectively, especially in front of non-technical audiences. You can learn more about it at teachthegeek.com. Again, that is teachthegeek.com. Today, my guest is Dr. Tod Pascal. He's an assistant professor in nanoengineering. His research involves studying theoretical and computational methods to elucidate the structure and dynamics of electro-chemical systems. I have no clue what that means, so I certainly will ask him about that when we start talking. And before that, he was a project scientist, and before that, a postdoc, and even before that, a PhD student. And he's lived all over the world pursuing his work, so I'm really curious to find out about how he came to nanoengineering, and in addition to how he goes about presenting such technical information. Welcome to Teach the Geek interviews, Dr. Pascal.
Thank you, Neil. Thank you for the invitation. Hello to all of your listeners, and Happy New Year. I think I might be the first one for the year.
Oh, well, I mean, you are the first one that I'm interviewing for this year, but because I might have a bit of a backlog, it may come out in a few weeks.
Gotcha.
But hey, Happy New Year to you in any way, because that is the time of the year right now. So from the bit of research that I've done on you, Dr. Pascal, I saw you got your background in chemistry. What was the interest in pursuing chemistry?
Chemistry was always a natural fit for me. I sort of, from my early days, was really interested in science. I was good at it. I was good at math. And I sort of, chemistry is the study of change. And basically it appealed to me because, I would look around and things would be changing, and my life in particular was always in almost seemingly in a constant state of change. And I was really interested in trying to understand, why things happened, and then in my later life, sort of trying to understand how we may start manipulating things to happen or to change in specific ways. And then, chemistry, as a high school student or even before that, chemistry is always, it's fun. You get to go in the lab and mix things together. I had a couple accidents when I was in high school, kind of, mixing together different compounds and having things start frothing up and exploding. And I'm sorry, Mrs. Steele, not catch fire. So it was fun. It was always something that you could do that was fun. Physics was fun too. Math was fun, but it was always much less hands-on than chemistry was. And so for chemistry, I got to do something that was hands-on and also something that was also quite fun.
Interesting. Well, you didn't stop just at a bachelor level. You went all the way to the PhD. So what was the motivation to get your PhD?
I had really good mentors. I had people who told me that they thought that I could do that. I did my, I would say one of the defining things for me was I did a summer research opportunity at Caltech where I ended up going for my PhD as an undergrad. And I met the person who would become my PhD advisor, Bill Goddard, during my summer research. And, he's an extraordinary man and sort of has this, insatiable appetite for knowledge and understanding materials and understanding engineering systems. And, working with him that summer really sort of crystallized within my head this idea that had kind of been bouncing around for a little bit. But that I wanted to go on and work in something that was new and interesting, at least interesting to me, and something that was really hard, and that was cool to me. And then during the PhD, I was thinking to myself, wow, you're really privileged here because people are paying you essentially to think about things, and that was cool. So all along the way, at every, it was not so much a plan per se, but as things went along, I started realizing that there might be a possibility here and there might be an opportunity here.
Was it always your plan to stay in academia, or did you ever entertain leaving?
Oh, I entertained leaving. I sort of and my trajectory is a little sort of non-standard in that after my PhD, I had an opportunity to go overseas, and so I went to Korea for about a year and a half. And there, I really just wanted to explore another country, of course, at a high level of doing research, but also see what else was out there. And so we did some really interesting work in Korea. And then I came back to the States, and I actually went to the national lab at Berkeley, so Lawrence Berkeley lab. And there, I was thinking, well, maybe the labs are actually really fantastic places to do research, and extremely smart people, top of the line equipment. And so I entertained, staying at the lab because it was really neat. Um, and Berkeley Lab is special in that it's so close to UC Berkeley, and you get students that are coming up all of the time. And in some sense, that actually motivated me to go back to academia. Sort of the idea that I could work with students. You could do that at the lab. There were a couple barriers, not many, but even just working with students, I was like, actually, what I really want to do is have my own research group with students that I'm able to work on interesting things with. And so yeah, an opportunity came up to come down to San Diego, and we jumped on it.
From the people that I know who are tenure track professors, once they get their PhDs, they often do postdocs. And as I mentioned in the intro, you did a postdoc. You were also a project scientist. Is it possible to get a PhD and go straight to being a tenure track professor?
Yeah, in certain fields, in engineering fields in particular, that happens. In the sort of natural sciences, or the sort of traditional physical sciences, physics, chemistry, math, and so forth, I would say it's possible, but if you want to go at a research institution, what is called an R1 school, it's a institution that primarily focuses on research. In the sciences, it's much more likely than not that you'll do a postdoc. But in the engineering fields, it is actually quite common to go straight from PhD into a tenure track position without a postdoc.
Why do you think that is?
That's a good question. It's a very good question.
That's what I do here, Dr. Pascal. I ask good questions.
Well, so I don't know, actually. I don't know the answer. I suspect that in the sciences, typically when you're doing a research project, at least for your PhD, then it's very focused on this sort of solving this one thing. And the idea for that, usually, at least, so I'll just talk about my experience. The idea for that project, usually something you either get from your advisor or you collaboratively kind of come up with together. And so the point of a postdoc in that sense would be for you to start exploring your own ideas, because you really don't get that much chance to do that in the sciences as a PhD student. But in the engineering fields, you're sort of working towards solving a problem, and then that sort of skill set becomes much more easily translatable to kind of starting up your own research group, because then you sort of have this experience of solving problems all the time, and so in your own research, then you can say, well, I'll just solve this new problem. So then this idea that you actually need to sort of take 1, 2, 3 years to develop your own ideas is not as strong. But it's a good question. I actually hadn't ever thought of it. It's just been traditionally that's how things have worked.
Okay, it's one of those. That's the way things have always been. So we're going to keep it going this way, man. I kudos to people like you, Dr. Pascal, who are willing to do it. I mean, for the people who I've interviewed that have those degrees in the physical and natural sciences, so not engineering, it seems like it's quite common for the PhD to take quite some time. Like I'm seeing like 6, 7, 8 years in the PhD program. And then after that, now I got to do a postdoc too. Like, when am I allowed to make money? I ain't trying to be poor like a priest forever.
It's a good question. I mean, I think in biology, for instance, the PhD program tends to take long, only because nature is and biology is not very cooperative. So you may be working on with fruit flies, for instance, and may have discovered this new pathway that sort of is going to extend the life of the fruit fly, let's say. But repeating those experiments becomes really, really difficult because biology is just it's subtle biology. Everything, life really, really exists in this very, very narrow band. And if you're going to try to change something about that, then getting that system to behave properly becomes really, 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 really challenging. So repeating biological experiments becomes a challenge. So the typical biology PhD takes a while. In I would say chemical engineering and chemistry, maybe 5-6 years. Physics, depending on what kinds of physics. So there are variations within the different disciplines, but it is not uncommon to have a 5-6 year PhD and then a couple more years for your postdoc. And so to your question about when do you make money, I think most professors, at least people who go into tenure track would readily admit that if they wanted to make money, then this is not the thing they would do. It's sort of it's a vocation in the sense that it's a calling. You sort of there are ways to make 4, 5, 6, 7, 8, 9, 10 times as much as you make as a professor doing something else, and so this is not why you do it.
I understand. I also mentioned in the intro that you're in the nanoengineering department, and I mentioned a bunch of words about what your actual research entails. So maybe you could give a bit more, I guess, insight as to what nanoengineering is and what exactly you do with your research.
Yeah. So as you mentioned, I was trained as a chemist, and my degree actually, my PhD thesis ended up being looking at disorder, so trying to understand disorder, if you will. It seems like a bit of an oxymoron, but if you have a system that is chaotic or not necessarily well behaved, then trying to understand how you can predict how that system would evolve effectively was my PhD thesis. So it was very abstract. I say that all to say that it was in this sort of niche abstract field. I found it super interesting. My advisor was super interested in it. But as I after my PhD, and I think this is maybe coming back to your question about the postdoc, I started thinking about, I wanted to get into something a little bit more applied, something a little bit more that I can kind of do hands-on things as opposed to just write equations all day. And so then I started thinking, okay, well, maybe material science would be good for me, that it's a good blend of, kind of fundamental kind of physics and chemistry and things that I know how to do. But it's also starting to get into real systems, and which is where I wanted to start going into. And so then that my postdoc at the lab then was in material science. And so when I was looking for faculty position, I was starting to thinking, actually, I really enjoy kind of living in this in-between world of, fundamental questions, writing equations and running simulations, but at the same time working with real systems. And so that was the motivation. And so the nanoengineering department at UCSD is actually set up exactly to do that, to pursue research into materials and material science, but at a very fundamental level, to really sort of understand how these systems work from base principles, as so-called ab initio, from the fundamental principles, fundamental physics, as it were. So that is the department. We have a ton of people who are involved at all levels in kind of material science and materials engineering, looking at it at a fundamental level. At this very nature, nanoengineering means that we're working at systems that are very, very small, nanoscale, so about a thousandth the size of a human hair. And so, trying to do engineering at that scale. And it turns out that doing engineering at that scale is very, very interesting, which is the word I would use. Everyone else would say it's extremely difficult and extremely complicated, because you have all of these, now you start having these electrons, and they're not really well behaved. At least we don't really understand them all that well. And so you're trying to manipulate sort of electrons and atoms and molecules to sort of make engineering structures. And so that's really, really cool. So what it is that we do. So we lie at much more of the kind of fundamental end of things. I think you've interviewed Darren Lapomi, and he sort of is much more sort of you're working with polymers that you can generate to make nanoscale systems. So we try to understand basically, say one of Darren comes up with this new polymer that could conduct electricity and bend and twist and do all of these things. We try to understand, okay, what about the structure of this polymer leads to the sort of properties that he's measuring. So fundamentally, we try to understand, why nanoscale systems behave the way they do, and approach that applying kind of fundamental principles of physics and chemistry.
You say that the work that you do, you find it interesting. Others might find it, others might find it deeply challenging. And then people from completely outside the field might just be like, I have no clue what these people are talking about. So, so you have all this technical information that you want to convey to people, and especially if they're non-technical people, it might be difficult to do. At least when I first started this whole podcast, it was based on me having to give these technical presentations in front of non-technical people working as an engineer and not being all that great at it. When did you realize that getting better at conveying technical information to non-technical people could be of benefit to you?
Oh, from the beginning, I would say. I mean, I think so I was always like I said, always interested in math, always interested in chemistry and science. And growing up, there were very few people around me who actually did much more than a high school level, got much more than a high school level education. My dad is an engineer, a computer science engineer, but he's the only one in my family who ever went to college and got his degree in computer science. So everyone else that I was surrounded around, incredibly smart people, but just hadn't gone through formal education. And they would always ask me, what is it exactly that you do? And even when I was in high school and I was studying chemistry and studying physics, no one else around me really had done those subjects. And so I was always having to explain, what it is that I was learning to them. And then later, once I started on kind of my career, explaining to them what it is that we're doing research-wise. So I always knew that science communication was important. That became much more crystallized when I was in grad school, and I realized, as I said before, people are paying you to think about stuff. Well, the people who are paying you is the taxpayer, and so what my former PhD advisor really impressed upon me is like, we have as scientists, we have an obligation to tell the people what it is that they're investing in, showing them why they should continue to pay taxes and support science. And so him and I, we ended up having all of these doing all of these outreach activities to the local Pasadena community, trying to engage people more. It was very important to him, and he impressed upon me that was our obligation as scientists, and it's something that I've carried with me throughout. And I would say, since I've been at UCSD, we've sort of built upon that even more, and we have a materials research center that we started a couple of years ago down here. And a key component of this materials research center is outreach and science education. And so, teaching our cohorts of students how to communicate science. And there we work with folks at the Fleet Science Center. It's a science center here in San Diego, on giving professional talks and, sort of to audiences that are non-technical. And all of the students get trained in that as a part of this center. And also, we have various symposia that we set up just so that students can talk to high schoolers and middle schoolers and the lay public about what it is that they're doing. So yeah, to answer your question directly, when did I know it was important? I knew it was important from the beginning, and everything that I have seen since has sort of just reinforced those ideas.
Is giving presentations or public speaking something you've always been good at? And if not, what'd you do to get better at it?
Well, I don't know if I'm good, but I've worked at it, and I think I've gotten better at it. It's for me. I don't know if I ever necessarily had a problem speaking in public. I think, actually, I'm pretty sure I didn't. I think my grandmother would agree with that. Just kind of impromptu speaking about things, whatever interested me or whatever was in my head at the time. But I enjoy it. I actually, it's the part of the job that I really, one of the part of the jobs that I really enjoy is kind of engaging with people and getting them excited. And whether that is students and kind of seeing that light bulb moment where something clicks in their head, or it's sort of talking to the lay public and just letting them know what it is that we do, and just seeing their oh, that is really cool, or seeing them make a connection as to, oh, this might actually help in X, Y, or Z, and seeing them make that connection. And so I really enjoyed that. I like the engagement, and it also I find that I learn so much by every single time I talk to somebody who's different, who has a different perspective, who asks a question that I hadn't thought about, like today, and it really gets me to think about that stuff. So yeah, it's fun to engage with people and to talk about what it is that we do, because I'm excited about it, and I like to see if always take the temperature to recognize whether I'm just this crazy man or whether or not other people can get excited about it as well.
Do you have a process for putting your presentations together? And if so, what is it?
Presentations, I'm not nearly that organized. I think, I usually start though with every slide that I have. I always have a question that I want kind of the audience, if they haven't asked, to ask themselves. And then at the end, I would have a statement answering that question. So that is my general process. I believe that slides should be minimal as possible, or at least, but convey the actual information quite succinctly and clearly. And so that's how I go about putting together my presentations. And in general, for talks, I try to have one or two central ideas that I'm communicating, trying to communicate, and then sort of build around that. And so I'm generally of the opinion that a presentation or a talk should tell a story and should have a central thesis. And so I like to talk about things, at least present things in that way, sort of just telling us stories, hopefully just one story.
Yeah, I'm a fan of stories too. And that wasn't something that I initially thought of, especially when giving technical presentations, but especially when you're talking to non-technical people, it can be a great way to just keep their attention and help them keep them engaged, especially if it's something they know absolutely nothing about. And I find myself, oh, go ahead.
Well, no, sorry, I was going to say that, we as a species, we're natural storytellers. Like, this is the beginning of everything for us, was, looking up in the sky and seeing a phenomenon and then coming up with a story to communicate to other people, what it is that we saw. And so people are just naturally, they can connect with stories, and presented that way, I think, sort of allows them into that space, but at the same time, sort of brings you into that emotional state where you can connect with them sort of directly through this very, very traditional kind of old school way of doing things, which is telling stories.
Yeah, no question. Do you ever get nervous before giving presentations? And if so, how do you deal with your nerves?
Uh, Not nervous, I would say. Usually excited. You know, I would be excited, and yeah, I mean, insofar as there's any nerves, it would be, I hope that the people get what it is that I'm trying to communicate to them, basically. Or, you know, I hope that at least my method of delivery is consistent with the story that I'm trying to tell. Um, so yeah, so I'm usually excited. I mean, and then what I've realized is, you know, usually sort of insofar as there is any anxiety, it's right at the beginning where you don't know how this is going to go. But then, you know, you just start talking. And again, you know, if you're telling a story, you just start the story, and then the first kind of engagement with the audience that I get, then it's, you know, it just kind of evolves from there, and the story tells itself, which is what I found. I mean, initially there's always some kind of apprehension, if you will, but then once you get going, I think it just flows and it figures itself out.
For those people who are listening or watching this conversation, what would the number one tip you'd have for them if they want to become more effective in public speaking?
Well, I mean, so for me anyway, it's the first thing is, you know, at least in my mind, I map out the story that I'm going to tell, and you know, it's all obviously useful to if you're going to give to a different kind of audience, to, you know, run it by other people who can give you tips and all of that. But I think that the first bit is just to know what you're going to talk about. There are some people that are extremely good at just extempo and just sort of go and off the cuff and can weave a beautiful story off the cuff. I am not one of those people. I need to sort of, in my mind anyway, have a mental board and a structure that I can follow, at least in my head. And I found that sort of just that kind of preparation reduces significantly any kind of anxiety that you would have. So that's number one. Number two, I think, is at least for me, when I talk to my students, it's always in this very, very technical way that we talk about specifics of their project. And when I first started giving talks, there was always this, I always fell into this sort of trap of talking to the audience as if they were my students. So sort of, you know, just diving into the sort of the super gritty, nitty gritty technical detail. And it took me a couple times to realize, you know, you really just kind of step back. You know, for a lot of people, this is the first time they're hearing about this. So, you know, presenting it in a way that sort of invites them in, and makes that kind of emotional and mental connection first before sort of delving into some hardcore specifics was quite useful, and so that you don't lose people. And then the third one is, you know, just read the room as you're going. So I like to have checkpoints, at least with myself. Now, every 5 minutes, I just sort of look up, you know, just stop saying anything and just look up for a couple seconds, just see where people are. I mean, are they tuning out, or his eyes started glossing over, or are they super interested, or are they writing? And then just adjust my delivery based on how it is that people are responding, right? So if people are super engaged, then, you know, all right, fine, you can kind of just pick up the pace and go. But if they're starting to have that glossy look, oh, then maybe I will go back and say, actually, you know, I really just want to go back to this point because this is a major point, and make sure that they get it, and then just take the temperature as I go, and adjust as necessary.
You know,
so I found those to be useful for me.
Well, thank you for offering 3, even though I only asked for 1. But I firmly take your point, Dr. Pascal, about having a structure when you're giving a presentation, I have a friend and he makes fun of me for the fact that I practice my presentations to make sure that I'm putting the information in the best way possible. Because you mentioned the people that are really great at speaking extemporaneously. I firmly believe that they aren't as good as they think they are, because they actually, well, if they actually gave some thought as to how should I present this information, like what should come first, what should come second, what should come third, if they thought about that kind of thing, especially when you're talking to an audience that knows very little about what you're talking about, you're making it much more likely that they'll actually be able to follow what you're saying, as opposed to it just coming out the way that it comes out. I mean, it's one thing to be able to speak without any filler words, no ums, no you knows, you so's. Oh, he speaks really well. But at the end of the presentation, if someone asks you, what did he talk about? Oh. But he speaks good, though. That's what I'm about. Well, this has been great speaking with you, Dr. Pascal. Thank you for being a guest. How can people get in touch with you?
Well, they can, drop me an email, tpascal@ucsd.edu. Or our research group is called the Atlas Materials Research Lab here at UCSD. Web address is cmp Charlie Martha Pierre.ucsd.edu. And yeah, I am generally interested in just chatting with folks about what it is that we do, and also, but just in what they think it is that we do. I actually found those conversations to be much more interesting, where people sort of tell me at least what they think that is what we do. Thank you for this. Thank you for reaching out and for having this conversation. I really enjoyed it.
Well, everyone, that marks the end of another edition of Teach the Geek interviews. My name is Neil Thompson, founder of Teach the Geek, and you can learn more about it at teachthegeek.com. Again, that's teachthegeek.com. Until next time, take care and stay safe. Thanks, Dr. Pascal.
Thanks, Neil.